So yeah, that's just a great thing to know at all points when it comes to all things Splunk licensing. So first place to start, if you don't already know, you need to get your current license state. So how well are you guys rocking and rolling pretty much? And you can do this with ingest-based licensing by going to the monitoring console or license manager. You can, or I will say you need to add up all of your licenses if you've deployed to multiple environments. It's important for you to get your full picture. We've ran across problems where people have the same license deployed to different clusters, and they're, getting, or they're actually having overages that they're not expecting because they're not centralizing that management. All the more reason to have a license manager, which allows you to coalesce your licensing in a single server. You can also get daily averages to effectively track your trends. This is excellent and useful for both methodologies. And with ingest, it's actually, you can really dive into the details of what indexing is taking up what percentage of your throughput. SVC. So SVC has been in a really iterative state thanks to the pretty quick development from Splunk side with their Splunk Cloud Monitoring Console. Definitely go into your Cloud Monitoring Console and dig into the workload preview dashboard. This is actually an optional dashboard that they're still cooking up, but we find that it provides a lot more visibility, a lot more usability than what you get out of the standard dashboards that they are replacing. So we really recommend right now, if you have Splunk Cloud, just opening it up and getting into this advanced dashboard. And a couple of those visualizations you do get from this new dashboard are like these. First of all, it's all like using their new React framework, a lot better visualizations and UI language, but you get the stacked chart here, which breaks down your ingestion by your processes. So you get ingest, search, and shared services. Just from awareness, shared services are things that are really hard to reduce. It's usually a fraction of your ingest on SVCs, or your SVC utilization, sorry. But search and ingest are the ones that you should really keep an eye on and track for spikes across the last, 14 days, 30 days to assess trends. You can also go by tier. So this is just another way to look at your indexer and your search tier as well. So once again, these are the preview dashboards for the new workload management or workload reports available to all Splunk clients on Splunk Cloud. All right. So here's the key thing that we all need to be aware of when it comes to Splunk limits and Splunk licenses. We should keep our Splunk environments geared towards the mission, make sure that we are able to have our Splunk environment be nimble and take new use cases. And we need to keep an eye on just our licensing. A lot of this responsibility for who tracks the license, it kind of falls through the gaps weirdly. Splunk admins are hired, they're brought on the team to make sure Splunk's running well, to bring technical minded expertise to the platform. And a lot of the times these Splunk owners or business owners don't realize that they need that technical boots on the ground to also be tracking their license consumption. And it's all very important because, as I said before, Splunk won't turn off if you go above your overages. And as this overages 11.2 section of the EULA shows, Splunk will, come back to you and say, hey, we noticed that you are exceeding your capacity of your user rights and that they have the right as offering a product and you agreeing to initial terms to come back to you and say, hey, this is the difference. And that is, a whole other conversation, but you need to treat the license seriously because Splunk treats it seriously. So it's very important to understand, and I recommend going to this URL. We'll be sharing this after this whole deck after this presentation. But go to this URL, explore, read a bit more into the EULA of Splunk, and just understand that you need to treat this license with the utmost clarity and ownership because Splunk is treating it with the utmost criticality, right? That is how they make money off their platform, and we got to use it effectively. So let's get into ingest license optimization techniques. The core three ways are we're going to be talking about unused data being indexed, unusable index data, and then duplicate data ingest, and how you can discover this and how we recommend fighting these battles here. So the first one, to properly review ingest space, proper management is required. This is a lot easier said than done. We'll be the first to admit here, but review of ingest is being utilized. Just because it's in Splunk doesn't mean it is useful, or it is being used. And in an effort to make sure you're optimizing your Splunk interest and your Splunk investment, make sure the data going into your Splunk system is actionable. Make sure it is being acted upon. If you're using Splunk as a data lake, you're wasting the opportunity and ability of Splunk on something that an S3 bucket could potentially just solve. And especially with recent Splunk improvements here, with ingest actions and routing, you can direct using Splunk tooling that, it's like Cribble, imitates that functionality, but it's just all Splunk and it's all free. You can reroute your data coming in to S3 buckets to save on indexing and save on computation. So we really recommend looking into that, seeing if it applies to your use case, because this is a key way for you to, put the low intelligence data where it belongs and keep Splunk open and able to attack high priority use cases. Because as we know, in this evolving landscape, new use cases will pop up. You'll ingest that data in Splunk, and you don't want to have a sit down conversation about what data needs to be turned off when you are at the cusp of a new and exciting mission that needs to be attacked pronto. The middle data point here, assign data owners and responsibility for ingest. This is just best practice. It's a change management database. We really recommend on the index or index source type level, going and saying, hey, this belongs to this person in this business unit, if possible. It's a really good way to structure your data, because then if you get outages or if you get overages of data ingests, you can know who to talk to and know how to split that pie moving forward when it comes to managing or even purchasing the Splunk platform for your business. So fix unusable ingested data. So just because data is in Splunk doesn't mean it's usable. And the first thing is you should really search for unsearchable. This is weird. Search for unsearchable future events. So a future event is a data coming in with a timestamp before real time. So you can get data coming in from tomorrow in Splunk, and Splunk will log that as ingest, but your searches and alerting won't be able to actually read it or leverage it because it's not in the past 24 hours. It's not the past 15 minutes. It's the future 3 days. This is a weird issue that comes up in Splunk more often than you might think, just because time zones are that tricky. They're that tricky for developers to manage. And just data formats can be weird, where you can get data that's being interpreted by Splunk as being from next week or next year. So it's really good to do an audit every so often of, hey, are we getting any future events? Let's go and fix these issues, because it's taking up space and you're not being able to leverage that data. It'll also point you to improperly formatted data to begin with. Next, we're here, unformatted default ingest. So in Splunk, you have these source types. It's what type that data is in, what format it's in. So you got syslog, default, unknown stash, JSON, CSV, just to name a few. These are pretty much the top offenders of just, hey, we're ingesting data in, I'm in a hurry, let's just assign it to one of these and then move on with my day. This is a potentially scary use case where by throwing data in these default source types, you are missing event details. So you're not getting proper event coming in, rendering the data kind of useless, especially when it comes to SIM compliance. This means that you should really triage how much your data is coming into these source types, especially unknown, right? You should definitely know what data is feeding the unknown source type. And you should see if A, it's actually usable, and B, hey, maybe we should redirect this to a different source type that's actually getting and collecting that data, or label it to ensure that it's properly tracked in the future. This could be a good source for just test data people have been sending into Splunk willy-nilly with forwarders set up on the periphery of your ecosystem, and should be worthy of just further analysis because you're potentially using a lot of your license on these kind of nothing burger data sets. And lastly, identify unworkable large events. So data coming into Splunk gets logged as events. You can have thousands upon millions of events per day, but you really want to identify any large events because it might be a smoke where there's a greater fire in your environment. These large events are difficult to search and they're difficult to manage, and it's difficult to for dashboards or for scheduled searches to really properly extract value out of it. And not only that, they're also larger, which means that you're using license on these large events that may be misproperly formatted, coming under bad source types, and just not being used. So this is a good, easy way to say, like, hey, what's actually the big elephant that we should go and start triaging? And so you see that this search here can help identify, the raw size of an event coming in and find large ones slipping through your initial net. Lastly here, duplicate data ingest. So it's, once again, important to know that all the data coming into your system is actionable, it's useful, and your full investment into your on-prem or in the cloud Splunk ecosystem is, money well spent. And duplicate data is really against that. It's just something that you've already seen, Splunk's already logged down to a T, and it's taking up space. We've seen a lot of clients with duplicate data from having different cloud or clustered systems that are sending data into Splunk, and all of their clustered hosts are sending the same data. This could be, a 5x, 10x duplication effect that can really take up space and literally provide you no additional context. So this is a really good one to triage and at least get a smell test. Of course, the rub here is that it's somewhat difficult to search for duplicate data unless you're doing a stats count by raw, which is a large search. So we recommend really going into this with narrow time ranges, or maybe even attacking specific indexes and source types one at a time, just so you can identify if there's any duplicate data coming in. So this search right here, stats count by _raw, this will identify if you're getting the exact same search duplicated in your environment. So that's timestamp, that's all the same punctuations, that's all of it, just the exact same thing appearing more than one time. And like I said earlier, it's a great place to start and identify, hey, this is weird and we should definitely look into it because we're now ingesting 2 or 5 of the same event, and why are we doing that? So yeah, the next steps, of course, triage and resolve. And of course, if there's a way or a reason behind this, leveraging the ingest actions to detect and reroute or even just stop ingesting of these features is a great use of core Splunk functionality built into the process already. So that's all for ingest there. And I would like to remind the license or the people on the ingest license that what I'm about to showcase for SVC consumption is still very important for the health of your system. So this is all good stuff going forward as well for you guys. Now for SVCs, everything I just presented, well, like I said earlier, ingest is part of your SVC calculation. So you should definitely keep all of that in mind when it comes to controlling your SVC license growth and ensuring that your Splunk Cloud deployment is able to keep up with the latest and greatest use cases. So the top causes of SVC utilization issues that we're going to talk about, it's going to be poor scheduler search habits, bad ad hoc search management, and once again, inadequate review of data ingest. So poor scheduled search habits. Here's the deal with the scheduled system. In Splunk, a lot of people treat it as a alert management tool, which makes sense. It's great at that. You schedule a search, it runs, it finds an error, it emails or creates a notable event on Splunk for you to track down. It's perfect. It's great. The problem is that Splunk is not Google. It's not something you just type in a search and press enter, and it will run it by itself without you looking. Each one of these searches will take power behind the scenes to run, and whatever schedule you give it, it will ensure that it will keep taking those resources on that schedule. That means if your search that you wrote or your users wrote is poorly configured, you're now running a poorly configured search over and over and over again, causing either technical issues on your on-prem environment, and we've seen really well-maintained Splunk Cloud environments. So props to Splunk Cloud's management team on this. But it will cause an increase in SVC utilization if you're not doing best practice for your scheduled searches. So that's the one thing you really got to look out for here. So one of the things we recommend, eliminating high frequency searches. So off the bat, a search that runs every minute or star, 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 if you know your cron, that is something that you as an admin team should triage and ensure that that is actually relevant and useful and needed. What's the difference of being alerted 1 minute after an event happens or 5 minutes after it happens? If you can't fix it within 5 minutes or within 1 minute, why are you getting alerted about it within 1 minute? By reducing the scope here from run every minute to every 5 minutes or every 10 minutes, or heck, even every hour, you might reduce the SVC drain of this search by a factor of anywhere from 3 to 10. So this is really important for you to play with and ensure that you're hitting that very good sweet spot of usability and usage of your resources so that you're using your SVCs wisely. So here's the next one. This one is a little bit interesting, but searches that run every hour but look at the past 24 hours of data. This is what we call a search coverage overlap. So this is where you have a scheduled search that runs for a set amount of time or on a set schedule, and it's over searching its schedule. So if you have a search that runs every day and it looks at the past 24 hours of data, perfect. If you have a search that runs every day that looks at the past 2 days of data, well, hey, that previous day was already searched by the previous time this search executed. But sometimes there's use cases for, sometimes you gotta get trend analysis, but a lot of the times you don't actually need to over search that data. It's just human instinct to build in this overlap that isn't actually required. You should look at these searches and ensure that your scheduled searches created by your users actually align the schedule to the time range when possible. This is a more frequent issue than you might think, and we really recommend looking into the APIs and figuring out ways to automate this process for you guys to flag these searches. If you have a lot of UI heavy users, this will happen by accident, just because if you change the schedule, it will not automatically change the time range, which is on the same modem. And as a side bit, I would also warn against the inverse of this. Search runs every hour, but only looks at the past 15 minutes of data. Hey, you're missing data there, buddy. So keep an eye out for that as well. Lastly, on this one, low use times, reschedule searches to low use time slots. So we all have a human nature, especially if you're not manually using cron to schedule your searches, to stack our searches up at the top of every hour. So when we say, run the search every hour, every 15 minutes, and so on, all of these run and cascade at the top of 3 sharp or 3:30, 3:45. This is a easy way to overburden your systems behind the scenes. And while, like I said earlier, Splunk Cloud will bend and actually reduce skips by a really good amount, it will do so at higher computational cost, which means that that's higher SVC usage. So we really recommend flattening the curve, if everyone remembers that lingo, and making sure that your scheduled searches are shifted throughout the time slots. And you can do that by changing the offset here. So instead of star divided by 5, which is every 5 minutes, it's 1 through 59 divided by 5, which is every 5 minutes, but starting at minute 1. So that actually doesn't change how many times it runs. It just changes when it starts. So use that mentality when reviewing a lot of searches, especially if a search is skipping or it's a large and impactful search. Offsetting that can free up resources for other searches to take its place. So next we have bad ad hoc search management. So every Splunk Cloud deployment has a workload management system. You can get it from the Cloud Monitoring Console. And this lets you set rules that help restrict how users interact with the platform. This is not done out of the box, and we really recommend your admins getting familiar and comfortable with these rule sets, because then they can actually restrict non-admins from searching index equals star. Index equals star is searching all your data. That means, whatever index I have access to, show me the data. Useful for admins when they're trying to triage outages or if they're just trying to manage their system. But as a user, we want to hold our users to a bit higher standards, because if they make a scheduled search that uses index equals star or index equals, win star, then they are wasting SVCs that will hit our bottom line of utilization. So if you put in this index equals star and role does not equals Splunk Cloud Admin, this will restrict users from leveraging wildcards like this. You can also restrict time ranges for non-admins. This is helpful because the longer the search is scheduled to run for, as in like last 7 days, last 30 days, last 60 days, the more SVCs it will take to execute, especially for with scheduled searches, right? Where if you misconfigure it, you're now misconfigured the search to run every day. So by limiting the time range, which is the total amount of time, that prevents users from going in there and saying, hey, I want to see the past 120 days of data of one event logs and hitting enter, which you might see on your bill. And lastly, disable real-time searches. So these searches are extremely niche, and whenever someone should build one, they should probably get guidance from an admin. But with these 3 rules here, you can definitely help control your environment more from an admin standpoint, and you're not just reacting. You're now limiting what your users can do, which is very helpful. It leaves you more time to do more proactive things elsewhere. So lastly here, we have inadequate review of data ingest. So data indexing takes around 20 to 40% of your SVC utilization. I'm sure some places it's lower and some places it's higher, but this is a rough estimate. So reducing over-indexing improves performance in SVC usage. There we go. So once again, just bring that mentality about managing your ingest into the cloud, and then you can actually reap a lot of benefits because you know who's in charge of what data set, you know why that data set's coming in, you know who to talk to if there's an issue, and you know that you're not over-indexing, which will actually lead to longer searches. Also, the data processor is a software that you can get, which lets you coalesce a lot of your searching. It's like a super heavy forwarder, for lack of a better term. And that lets you do redirects and pipelines before it even hits cloud. So with all of these techniques, we really recommend all of you just identifying your current license status and your current trends and review the optimization of your current license usage. We want to all stay fresh and nimble with our Splunk systems. So when the next thing happens, when the next fire erupts, we know that our Splunk system can handle it, and we don't all have to, start drawing short a straw for what use case gets turned off. Finally, we want to also resolve the issues found and optimize your license. So this just 3-step flow here will really help you set a good path for 2025 when it comes to your Splunk licensing. And of course, here at Presidio, we'd love to just say we're here to help. We have Atlas Assessment, which all of you can access on Splunk Base. This does a lot of the checks that I talked about today. It will give you a red, yellow, green, and we're constantly improving it. We've actually recently doubled the amount of checks on there. We also have the Atlas Foundation Suite, which is a software tool which provides optimization of indexing and search. So if you're interested, reach out for that. And we also have a PS, or professional services team, where we can do a Splunk health check and basically do all this for you and give you a executive level or detailed level report that you can take and resolve your actions with. But with that, yeah, thank you for your time. Hope you guys learned something and got some more information how to manage your Splunk optimization of your license out of this. Hope you guys have a great rest of your day. Once again, feel free to leave a comment if you have anything, any other questions, or reach out directly to me. That's gbrantley@presidio.com. But yeah, thank you for your attendance, and hope you have a great rest of your day.